Hi there. Find the remainder if 2015 raised to 2016 plus 2015 raised to 2015 plus 2015 raised to 2014 plus and so on plus 2015 plus 1 is divided by 2016. Before we start solving this one, feel free to pause the video so that you may try this one first on your own. Okay, good. So let us start. To solve this, we'll be needing the concept of modular arithmetic. So there's a lot of things that needs to be said in order to discuss this one, but in a nutshell, when we say modular arithmetic, this tells us that if m divides a minus b, wherein m out here is a natural number or a positive integer, and a minus b out here, or a and b, are integers, then we can write this as a is congruent to b modulo m. So there are a lot of applications for modular arithmetic, and one of those is finding the remainders of a given number. So for instance, let's have this example. So we have 7 is congruent to blank modulo 5. To find this missing out here, we can divide 7 by 5, and the remainder that we get out here, we can plug it in here and we'll see that this holds true or is valid. So we have 7 divided by 5. So we know that we'll have here 1. 5 times 1 is 5. Subtract these two and we get 2. So 2 out here is the remainder. So plugging in 2 in our congruence, and we have this. Take note that this is valid since we have 5. So this one, we have 5 divides 7 minus 2, and 7 minus 2 is equal to 5. And we know that 5 divides 5 is trivial and is always true. So this congruence out here is indeed true. So as you can see, this form out here is a nice representation of what the remainder is out here when we divide these two numbers. But aside from that, the nice thing about modular arithmetic is that we can represent this number out here in another form or another number if this one is not really nice. And you'll see later on in our example. But aside from this, take note that if we add 5 out here, so 2 plus 5, observe that the congruence will still hold. Indeed, if we have, so 2 plus 5 is 7, so we have 7 is congruent to 7 modulo 5. And if we check, 5 divides 7 minus 7, which is equal to 0, and we know this to be true since 0 divided by any number is always true, or 5 or any number divides 0 always. If we keep on adding 5 again out here, so we add another 5, we'll have 7 is congruent to 12 modulo 5. Take note that this is also valid, as you can see out here. Aside from adding out here, we can also subtract in this one. If we subtract 5 out here, we'll get 7 is congruent to negative 3 modulo 5, which is also true since observe that 5 divides 7 minus negative 3 is 10, and we know that 5 divides 10. So this one also holds true. Lastly, if we subtract another 5 out here, so we'll have 7 is congruent to negative 8 modulo 5, which is also valid. So as you can see, just by knowing this remainder out here, we can represent it into this form, into this, and into this when we deal with modular arithmetic. You'll see its nice application later in our exam. So try to digest this info first before we proceed to our actual solution. So let's now start. So first thing to do is let's try to inspect what happens when we divide 2015 by 2016. So we have 2015 is congruent to blank modulo 2016. So let's find the remainder. We know that 2015 divided by 2016, so we have this one. We know that the largest possible number that we can put here is just 0 since 2015 is smaller than 2016. So 2016 times 0 will be 0, subtract these two, and we get 2015. So 2015 out here is the remainder. So we plug it in out here. And upon obtaining this, we can't really do anything out here since this outcome is not really nice. But take note that we can apply what we learned earlier, and let's try to subtract or add 2016 out here. Observe that if we subtract 2016 out here, so we'll have 2015 minus 2016, this will give us -1. And from a while ago, we know that this means that 2015 is also congruent to -1 modulo 2016. And we'll use this one out here since it looks nicer, and it's using this one, it's easier to find the remainder for other powers of 2015. So take note that in modular arithmetic, since we're dealing with congruence, what happens to one side also happens on the right side. So it's just like equalities. So if we square this one, we'll get 2015 squared is congruent to 1, since -1 squared is 1 modulo 2016. Similarly, if we cube 2015, we'll get 2015 cube is congruent to -1 modulo 2016. Actually, we can repeat this process up until 2016 and we'll have a better understanding of what the remainder is of each of these terms. So using this concept, we can generalize this one, that 2015 raised to an odd number will give us, or is congruent to -1 modulo 2016. And if 2015 is raised to an even number, then this one is congruent to 1 modulo 2016. So in modular arithmetic sense, this tells us that the remainder for 2015 raised to an even number is 1, and the remainder when 2015 raised to an odd number is equal to -1. So this is just a representation again. This is actually 2015. But observe that there is actually a nice part out here. Since if we check the given, so we have 2015 raised to 2016 plus 2015 raised to 2015 plus and so on up until this 2. Take note that this one is congruent to, so their counterparts, this one, so even, so this one is congruent to 1, this one is congruent to -1, this one out is congruent to 1, and this one out is congruent to -1. And of course, this one is just congruent to 1, so it just itself. So we'll have this out here. And observe out here that if we try to group these terms, so we can pair this and this. In fact, there are also a lot of pairs inside. Moreover, take note that these pairs are exact, since from 2015 to 2015 raised to 2016, we have a total of 2016 terms, which we know that when we pair, there are no x's. These means that we have 2016 pairs, or rather, 2016 divided, that is 1008, I think 1008 pairs of 1 plus -1. So this means that 1 plus -1, we know that this just becomes 0. And and also this, it is also the same for the terms inside. So sorry for my buckling. then 1 plus negative 1 out here will also be 0. Just to take note that it might confuse you, like, why do we have negative values out here? But take note that the same idea applies, since if we treat this as 2015, so we have 2015 raised to an odd value plus 2015 raised to even is congruent to 2015 plus 1, which we know to be equal to 2016. And 2016, since this one is modulo 2016, then this one is just the same if we subtract 2016 out here. So this one is just the same as 0. So as you can see, even though we used a different representation for 2015 out here, even though we used negative 1 instead of 2015, the same idea applies, that the remainder is 0. So given that, we'll only be left with this one out here, which is 1. And since 1 out here is the least positive congruence, then take note that the least positive possible value out here, modulo 2016, represents the remainder of this sum out here when divided by 2016. And so this out here is our final answer. So it is really important to have a background on modular arithmetic in solving this one, since if you don't have a background on this one, I'm not really sure how we can solve this. But if you have any idea on how to solve this without using modular arithmetic, feel free to comment it down below and I'll be glad to hear from you on how it works. So yeah, I hope you got and understand this video. Sorry, I'm kind of buckling a lot. Yeah, I hope you still got the solution and the idea on how to solve this. But again, if it is quite confusing, just comment down below and I'll try to explain how it works much better. So yeah, that is it, and that is all for this how to solve video.